Welcome to our exploration of a groundbreaking frontier in agriculture, space farming. As we look to the stars, we find potential solutions to some of Earth's most pressing food challenges. In this video, we'll delve into the fascinating world of growing food in microgravity environments, highlighting why algae could emerge as the next superfood. Join us as we uncover the role of space agencies, the impact of genetic engineering, and the psychological benefits of farming beyond our planet, all while considering the unique challenges and future prospects of this cosmic adventure. 1. The allure of space farming. The idea of growing food in space has captured the imaginations of scientists and dreamers alike. Space farming, as it's often called, isn't just a futuristic fantasy. It's a practical necessity for long-duration space missions. NASA and other space agencies are keen on finding ways to grow food on the International Space Station, ISS, and beyond. This isn't just about sustenance, it's about sustainability. In space, everything is recycled, and food is no exception. Researchers are exploring how to cultivate crops in microgravity, which could lead to new agricultural techniques here on Earth. Imagine a world where we harness the power of space technology to grow crops more efficiently and sustainably. 2. Microgravity. A game changer. Microgravity is the condition in space where gravity is much weaker than on Earth. This unique environment presents both challenges and opportunities for growing food. Plants behave differently in microgravity, and scientists are keen to understand these changes. For example, without the pull of gravity, plants may grow in unexpected ways, potentially leading to new varieties with unique nutritional profiles. The absence of gravity also affects how water and nutrients are distributed within the plant. This could lead to more efficient farming techniques that reduce the need for water and fertilizers, which are scarce resources on our planet. 3. Algae. The space superfood. Algae are tiny, plant-like organisms that thrive in water. They're often touted as a superfood because they're packed with nutrients like protein, vitamins, and minerals. Algae are already being used as a food source on Earth, but their potential in space is even more exciting. They grow quickly, require minimal resources, and can be cultivated in closed-loop systems, making them ideal for space missions. Moreover, algae can produce oxygen through photosynthesis, which is crucial for maintaining life support systems in space habitats. This makes them a versatile and sustainable option for feeding astronauts on long-duration missions. 4. The role of space agencies. Space agencies around the world are investing heavily in research to understand how best to grow food in space. The European Space Agency, ESA, and NASA have both launched projects aimed at developing sustainable space agriculture. These initiatives are not just about feeding astronauts, they have the potential to revolutionize agriculture on Earth. By studying how plants grow in space, scientists can develop new techniques for growing crops in challenging environments, such as deserts or urban areas. This could lead to more sustainable food production methods that help address global food security issues. 5. Genetic engineering in space. Genetic engineering is another exciting avenue for developing space superfoods. By modifying the genes of plants, scientists can create crops that are better suited to the harsh conditions of space. For example, researchers are working on developing plants that can withstand high levels of radiation or low temperatures. These genetic modifications could also lead to crops with enhanced nutritional profiles, providing astronauts with the nutrients they need to stay healthy during long missions. This research could also have applications on Earth, where genetically engineered crops could help address issues like climate change and food scarcity. 6. Space crops. A new frontier. Space crops are plants that have been specifically developed for cultivation in space. These crops are designed to thrive in the unique conditions of microgravity, with minimal resources. Scientists are experimenting with a variety of crops, from leafy greens to root vegetables, to determine which are best suited for space farming. The goal is to develop a diverse range of crops that can provide astronauts with a balanced diet. This research could also lead to new varieties of crops that are better suited to growing in challenging environments on Earth. 7. The economics of space food. The cost of sending food to space is astronomical, pun intended. Every kilogram of food sent to the ISS costs thousands of dollars. This makes developing sustainable food production methods in space a financial necessity. By growing food in space, astronauts can reduce their reliance on costly resupply missions. This could lead to significant cost savings for space agencies and make long-duration missions more feasible. Additionally, the technologies developed for space farming could have economic benefits on Earth by reducing the costs of food production and increasing yields. 8. The psychological benefits of space farming. Growing food in space isn't just about nutrition, it also has psychological benefits for astronauts. Tending to plants can provide a sense of normalcy and connection to Earth, which is crucial for maintaining mental health during long missions. The act of gardening can be a therapeutic and rewarding experience, helping astronauts cope with the isolation and confinement of space travel. This aspect of space farming is often overlooked, but it's an important consideration for ensuring the well-being of astronauts on missions to Mars and beyond. 9. Challenges of space agriculture. Despite the potential benefits, space agriculture faces significant challenges. The harsh conditions of space, including radiation and extreme temperatures, can make it difficult for plants to survive. Additionally, the limited space and resources available on spacecraft and space habitats pose logistical challenges. Researchers are working hard to overcome these obstacles, developing innovative solutions to ensure the success of space farming. These challenges also provide valuable lessons for improving agricultural practices on Earth, particularly in regions with harsh climates or limited resources. 10. Looking to the future. The prospect of space superfoods is an exciting frontier in the world of agriculture. As researchers continue to explore the possibilities of space farming, they are uncovering new ways to grow food more sustainably and efficiently. This research has the potential to transform not only how we feed astronauts on long-duration missions but also how we approach agriculture on Earth. By harnessing the power of space technology, we can develop innovative solutions to some of the most pressing challenges facing our planet, from food security to climate change. The next superfood might just come from the stars.